So, in the previous class we had been discussing components of milk, and we were at carbohydrates of milk, right. So, in this dairy and food process and products technology, in this course, lecture number 34, we still do with the carbohydrates in milk, right. So, we stopped at some place where we saw that the major carbohydrate in milk is lactose, and this lactose we normally call it to be, and if you remember, sometime we said that this is the only natural product where the only one carbohydrate is there. The reason being, because others are so small in quantity, so they are negligible, and that too, since lactose is there, and we know the chemistry of that on hydrolysis of lactose it produces glucose and galactose. So, one molecule of water comes out when glucose and galactoses are fused to form the lactose. So, lactose on hydrolysis in any case produces that, though I am not saying lactose is so easy to hydrolyze into galactose and glucose, but there could be some possibility, and also it could be naturally already present there, but the quantity is so less that we consider that milk has a single carbohydrate, that is the lactose, right. Now, let us look into how much quantity it has. Minerals in milk is about 0.7 to 0.8%, 0.7 to 0.8% of sodium, potassium, calcium, sodium potassium chloride, which are readily diffusible and their concentrations are negatively correlated with the lactose, right. So, what does it mean? That their concentrations are negatively correlated with lactose. That means, if lactose concentration goes up, then this availability of these minerals are less. So, that is why negatively correlated with the lactose, right. And generally this sodium, potassium and chloride, they are available as the free ions. So, they can also, as and when required, they can also join with others whenever it is required. So, these free ions, sodium, potassium, calcium, chlorine, chloride rather it should be. So, out of which two are anions, two are cations and one is anion. So, they can bind with many others as and when required. Now, concentrations of calcium, magnesium, ionized phosphate and citrate depend on the casein content in milk, right. So, that means, if the casein content is high, then we get more calcium, more magnesium and more phosphate. These we get more. The reason being, when we have covered casein, you have seen that these minerals, they are clubbed with the casein, right. They are clubbed with the casein, they are forming the bond with casein. That is why, if the casein is high or concentration of casein is high, our corresponding this mineral availability is also high, right. So, more casein, more calcium and more phosphate and more magnesium. So, calcium, magnesium, phosphate are related with the casein positively, that more calcium, more these ions or these minerals we get, right. Then concentration of citrate varies depending on the season and feed of the animal. So, whatever be the animal, if it is cow, normally that milk synonym we have cow, because almost all of us do drink this cow milk. Yeah, many others also do drink buffalo or maybe some other animals like goat or etc., wherever it is available. But by and large, in general, we make that milk as a synonym of the cow. That is, milk means cow, it is the cow milk. So, it depends on the season and also the feed, right. The citrate concentration availability depends on the feed as well the season, right. It is not throughout the season the same concentration of citrates will be available. As well, if the cow is or the animal is fed with good material, then you will have one kind of citrate concentration, and if it is based on the pasture which is available in nature here and there. So, if that be, then another kind of citrate concentration you will get. So, these two directly affect the citrate concentration availability in milk. Okay. Then, which affect the soluble calcium content and milk stability. That citrate concentration is dictating or is monitoring the availability of the calcium. So, if the citrate is available, that is much better, because it is also soluble calcium content that will be dictated by the concentration of the citrate. There is an equilibrium between colloidal dispersion and salts. Normally, salts we mean that, by and large, salt we mean that it is soluble in water. By and large, I am not saying all salts are soluble. There are many soluble salts, there are many sparingly soluble salts, there are many salts which are not soluble at all, right. Of course, at all cannot be, because it is relative, right. So, whether it is in ppm or ppm means parts per million or parts per billion or even lower. So, that is different. Normally is not to the level of ppm, we say that this is soluble, that means it is having a good concentration. So, that is being controlled, the calcium. We said that calcium is bound with the casein. So, the casein is dictating the availability of the calcium, but the citrate concentration is also dictating availability of calcium in the soluble phase, right. So, the calcium availability in the soluble phase is dictated by the citrate concentration, and which may contribute, which may dictate or which may control the equilibrium between the salt and the colloidal state, right. So, if the colloidal equilibrium is destabilized, then concentration of minerals may affect the processing, right. Obviously, when you are processing milk, processing normally it is with respect to heat treatment by and large. So, milk is first heated. You will not see any other that milk without heat treatment, it is cooled and kept at low temperature. The reason we have said earlier, but okay, since it has come, a repetition it could be, but maybe recapitulation for you, that the reason is milk contains lot of enzymes lot of microbes. So, they may spoil milk if they are not deactivated before it is cooled. So, that is why the first step whatever you do with milk is the heating, right. Now, when you are heating, this disturbance of the colloidal solution, that may affect the process, because if sometimes something comes out from the medium, that is milk, then your that process may be affected both in terms of heat or mass transfer. So, in that case your destabilization of the equilibrium of the colloidal state is must or is affecting your process, right, which require that the addition of anions to bind to ionic calcium that would restabilize the casein against aggregation, right. So, as we said that if casein is destabilized, that is casein is in the colloidal state and that too with calcium. So, if the destabilization is taking place and if that is not again brought back, who will bring back that this ion, that is anions which are available. So, citrate is one such anion. So, that anion will help to bind back the calcium, in turn your casein, and the stability of the colloid will be brought back. That is why the concentration of citrate is so important, that it will help stabilize, making the equilibrium between the your this colloidal state and the solution state. So, this citrate is playing an very important role in stabilizing the colloids in the milk, right. Now, at some times salt is also added. Salt is also added as an additive in certain dairy products. This salt is added, the concentration of calcium in milk is relatively high, and for this reason milk is considered to be very important source of calcium. Primary salts in milk are phosphates, citrate, chlorides and sulfates, carbonates, bicarbonates of sodium, potassium, calcium, magnesium, right. So, in as we were saying in the the stability of the your this thing, stability of colloid, this colloidal stability, for that sometimes some salt may be added externally, right, and this external salt addition will help to stabilize the colloidal suspension of milk if required. Again I am saying if required, because when you are processing, and processing is with respect to heating. So, if heating during that, if there is some disturbance in the colloid, then casein will come out. So, losing calcium, losing casein. So, they are to be brought back to the colloidal state or in equilibrium between colloid and the solution. So, that can be done by the addition of this salt, and normally milk contains these phosphates, citrates, chlorides, then sulfates, carbonates, bicarbonates of sodium, potassium, magnesium, calcium, all these, right. Of course, level of salt is not equivalent to the level of minerals. How much salt is added or how much salt is there in milk, of course, it does not tell. I mean, it is not proportional that so much salt means so much mineral available. The reason being, some minerals could be bound which may not be available for other activities. So, it just cannot be said directly that salt concentration or salt present is equivalent to so much of the mineral availability. Level of salt is also by no means equivalent to ash content. As we said in the very beginning that milk do have basically the nutrients, basic nutrients, that is fat, protein, carbohydrate, then vitamins, minerals and water, and these vitamins, minerals, water, they are not water is shown separately when it is in tabular form, but it is said that water, fat, protein, carbohydrate and ash content, right. So, ash content we have seen it varied very widely, maybe from decimal to some units, right. So, depending on the source, etc. So, but it does not corroborate that if ash content is high, that will dictate the mineral content is also high, right. There are many others for which the ash content could be high, but the mineral content may not corroborate with the high concentration or high availability, high number of ash content, right. So, that we have to keep in mind. This may be due to the many others which are not in the family of fat, protein, carbohydrate. So, they may come crude fiber, crude things. So, they may come into the ash content. So, this ash content does not reflect the availability of the minerals, right. So, this influencing factors for salt composition are species, breed of species, stage of lactation and feed. So, obviously, the salt concentration varies depending on species, breed of species, stage of lactation and also the feed. Stage of lactation is one vital parameter, feed is another vital parameter, though species and breed are also, but feed is definitely a vital parameter, because as far as unorganized sectors are there. So, individual rearing of these animals are there. So, it is everybody wants that give less, get more. So, the cow is fed with the minimum or from the natural sources, and we want maximum output from the cow, right. That is not possible. Whereas, in many countries, in many I do not say developed, underdeveloped, because that has no meaning. In many countries, there are that consolidated or concise or collectively the rearing of these animals, and their feed is well controlled. With all other parameters, feed is also well controlled, well fed, and they do give really good quality and quantity, because it is not only the quality, but also the quantity that will be dictated by the feed, and of course, other parameters like your the breed or the species or maybe the period of lactation or many others, right. So, this we have to keep in mind that feed is primary. So, wherever possible, try to impress on the people who are rearing that if they should allow the animal to be with proper feed, right, to be fed with the proper feed, that will also give you in turn good return of the quality and the quantity of the food of the milk, right. So, this you must convey or you must pursue, right. Okay. Now, remaining portions together with magnesium are partly in suspension and partly in solution. This remaining portion I am saying that with respect to perhaps the casein content, right. Small portion of sulfur enters into, no, this is with respect to whey protein, sorry, with respect to whey protein, right. So, small portion of sulfur enters into the composition of the casein and lactalbumin. Oh, this is with respect to the mineral content, right. So, this is small portion of sulfur and that enters into, small portion of sulfur enters into the composition of the casein and lactalbumin, right. All the needs of an adult, that is why it is not the complete food, right. Now, minor constituents which are there in milk are, minor constituents which are there in milk are, yellow color of milk is due to a pigment known as carotene, that is the pigment which is available in milk. Phospholipids, that is lecithin. This lecithin is the fat-like substance containing nitrogen and phosphorus, and this lecithin is the binder between the fat and water, right. So, this is the intermediate between fat and water and or mediator between fat and water to be in the same platform, in the same place. So, that lecithin is another small constituents of milk. Fishy flavor of butter, a common defect is due to the decomposition of this lecithin. Sometimes there may be some fishy flavor availability or fishy flavor may come up. So, that is primarily due to this decomposition of lecithin, and subsequently it turns to be maybe TMA, that is trimethylamine, or TMAO, trimethylamine oxide, by which normally fish is recognized or fish is judged whether it is already it has gone wrong or it is spoiled or it has started. So, that number TMA, TMAO helps, but this is the obnoxious smell is primarily due to the decomposition of this lecithin to those amines, right. In the splitting of lecithin, trimethylamine is formed, which is responsible for this fishy flavor. Yeah, as we discussed that this fishy flavor is primarily due to the trimethylamine, which is obtained by the decomposition of the lecithin, right. Then some other small quantity, small portions of different materials are like cholesterol, right. Cholesterol is also one material which is available in milk. So, and milk contains around 105 to 175 or 76 parts per million, right, parts per million. So, 105 to 176 parts per million cholesterol is there. Just for your rather information, I tried to give that is why I said. So, as a you see how complicated they are. This lecithin is this. Lecithin is this with a phosphoric acid group, right? And there is also the other one, that is you have hydrophilic and hydrophobic, both are there, right? And similarly cephalin, another, this is also used as your binder, that is between fat and water. So, you see how though it is on the another background. So, that is why some portion is not visible, but this is of course this is CH3, this is also CH3, and this is the cholesterol. You see how many numbers of this your 6-membered or 5-membered rings are there, as well the side chains are also there. So, it is complex. Cholesterol is also complex, lecithin is complex, then cephalin is complex. These are very complex compounds, right? And I do not expect that you will also remember them. So, big things are not required, because as and when you need, you can go back to that and you can tell, right. So, if we go back to that, so let me bring back this to its original position. There is a saying, if you have a knife, you can use it to cut your hand, or you can use it for some good purposes, right. So, okay. So, cholesterol is this is what that I with reference to this advanced technology for this interaction with you, this advanced technology when you are using, obviously we have to be also accustomed with that, and a little time also has to be given. So, cholesterol is around 105 to 176 parts per million. Since our time for this class is almost over, we will also come back to cholesterol in the next class, start with that. But before that, let me also tell this, that nowadays, earlier we had a mind in our mind that cholesterol is bad, there is LDL and HDL, and depending on this high density lipid or low density lipid, depending on that, so people used to take their food, etc., etc. But recently some scientific investigations have said that no, it is not the cholesterol, so it is not so bad as it was thought of, that it is like a giant, it will spoil you, etc., etc., may not be. However, that is another part, that is not part of our interest at this moment, but our interest is that this cholesterol is also available in ppm level. Okay? Time is up, let us stop it today. Thank you.